Welcome to This Explainer. Today, we're going to unpack the invisible blueprints that quite literally shape our modern world through computer-aided design and drafting, or, as we all know it, CAD. Think of it as the digital DNA of modern manufacturing and engineering. But before we get totally bogged down in the technical details, I want you to just look around your room. Seriously, take a quick glance. Have you ever stopped to ask yourself how a simple idea in someone's head eventually becomes the buildings we live in, the chairs we sit on, or the circuit boards powering the device you're using right now? Well, the answer, almost universally, starts with CAD. To demystify this superpower, we're going to follow a really clear roadmap today. We'll start with the blueprint of everything, move through the CAD design workflow, peek inside the Drafter's Toolkit, explore the industries built on CAD, glimpse into the future of design, and wrap up with your career in CAD. All right, Section 1, the blueprint of everything. Let's take a quick trip back in time. Pre-1980s, drafting was entirely manual. Picture giant rooms filled with massive paper tables, rulers, T-squares, the whole shebang. Then, the 1980s hit us with a massive wave of CAD software adoption that moved all that painstaking work onto computer screens. Fast forward to our present era, and we are right in the thick of a massive cloud and AI evolution. This is pushing speed, accuracy, and the ability to make easy revisions to totally unprecedented levels. Now, you've got to understand the massive leap between flat 2D drafting and deep 3D modeling. 2D drafting handles your essential engineering documentation, right? Your flat floor plans, cross-sections, and precise dimensions. But 3D modeling? That brings those concepts to life. It lets engineers visualize individual parts, test out complex mechanical assemblies, and literally get the complete visual picture of a design way before it ever physically exists. Moving right along to Section 2, the CAD design workflow. So the absolutely crucial point here is that we aren't just blindly drawing lines on a screen. Engineers follow a very strict logical sequence. It always starts with gathering exact requirements. From there, it moves to a rough sketch, which is then formally drafted out. Once that draft is rock solid, we build the full model. And it doesn't stop there, actually. Every single design goes through a rigorous review process before outputting the final documentation. It is a highly structured path from concept to reality. Okay, Section 3, inside the Drafter's Toolkit. Let's look at the tools of the trade. I want you to think of these essential commands as the fundamental alphabet you use to write the story of a machine. Inside interfaces like AutoCAD, using the ribbon and command line, drafters rely on core drawing commands. We're talking line, circle, arc, polyline, and rectangle to build raw geometry. Then they manipulate that geometry with really powerful editing commands like move, copy, trim, offset, and fillet. It's an incredibly robust digital vocabulary once you get the hang of it. And to maximize productivity even further, drafters use a brilliant feature called blocks. Basically, blocks are reusable objects that contain specific attributes. Imagine you need to place the exact same complex window in a floor plan 50 times, or maybe the same standardized bolt in an assembly drawing. Instead of redrawing it every single time, which would literally take forever, you just insert the block. It saves massive amounts of time and guarantees total consistency. But, we do have to anchor this in reality. On the plus side, CAD offers incredible accuracy, huge productivity boosts, significant long-term cost savings, and insanely easy revisions. However, it does come with a few limitations. You're dealing with a pretty steep training curve, substantial software licensing costs, and very strict high-performance hardware needs just to run these intensive programs smoothly. That brings us to Section 4, Industries Built on CAD. Whether it's the microchip inside your phone or a massive suspension bridge spanning a bay, CAD is everywhere. It's used for laying out complex electrical circuit panels, designing crucial infrastructure in civil engineering, and utilizing CNC and sheet metal production in manufacturing. You'll see it absolutely everywhere in mechanical engineering for intricate machine parts, and it's heavily utilized in architecture for comprehensive floor plans, elevations, and building information modeling, or BIM. And of course, different software tools are specifically tailored for different industry applications. Programs like Revit, they heavily dominate architecture and BIM. If you're in manufacturing or mechanical design, SolidWorks and Fusion 360 are generally your go-to solutions. For versatile, general drafting, AutoCAD remains the absolute gold standard, while programs like CATIA and Creo step in to handle highly advanced 3D engineering tasks. Now, to ensure everyone speaks the exact same design language across all these different platforms, We rely on strict industry standards like ISO, ANSI, and BIS. These standards are what allow us to take a real-world case study effortlessly from a basic building plan, translate it perfectly into a fully realized 3D model, and finally generate exact, actionable construction documents. It basically guarantees global consistency. All right, Section 5, the future of design. Where is this all heading? Well, one of the most fascinating leaps forward we're seeing right now is the concept of digital twins. A digital twin is exactly what it sounds like, an identical virtual asset of a physical building or a piece of machinery. We use them for real-time monitoring. You can literally test stresses and predict failures on the virtual model before anything ever happens to the real-world object. It's a total game changer. Combined with digital twins, the future scope of CAD is expanding exponentially. We are seeing AI actively driving generative design, where the software literally helps optimize and invent entirely new structures based on your specific constraints. It honestly feels like magic. Add in heavy automation, deep cloud integration, augmented and virtual reality, and the broader shift toward Industry 4.0, and CAD is rapidly becoming a deeply intelligent collaborative design partner. Finally, Section 6, your career in CAD. As you can imagine, the demand for these skills is incredibly high. You can leverage this knowledge to pursue highly rewarding careers as a CAD designer, a draftsman, a design engineer, or a BIM modeler. And you know the absolute best way to stand out in the job market? Validate your expertise with official industry certifications directly from the major software developers themselves, companies like Autodesk, Dassault, and PTC. If you are stepping into an interview for one of these positions, you need to be fully prepared to answer some core foundational questions. Expect them to ask you, what exactly is CAD? Can you clearly articulate the specific differences between 2D and 3D? How do you organize a drawing using layers? What is the function of blocks? Master these and you prove you have the solid technical foundation needed to succeed. So, armed with this comprehensive understanding of the invisible blueprints shaping our entire modern world, from those fundamental drawing commands to the AI-driven digital twins of tomorrow, the only question left to ask is, what will you build next?